Alright, it's time for us to dive into some transformations. That will include translations, reflections, and rotations. Let's take a look at this in real-world context first, and then we'll dive into a little more math lingo as well. Okay, so looking at this picture here, what do we see exactly? There's a few things that I personally see. One, let's go with this. You see this triangle-looking piece right here? Sure looks like this is the same over here. And if you were to draw a line right through the truss, you would notice that this basically just ends up reflecting over that vertical line. Sometimes that might be like our y-axis, or maybe another vertical line like an x=2 line or something like that if we're talking about on an xy coordinate plane. But in real life, when we're looking at that, hey, look at that, it's a reflection right over that center of the truss. Okay, what else do we have? Let's get rid of those. What else do we have on this guy? Well, what I see is a bunch of identical trusses moving back, right? We've got this truss up here, right? We got another one, yeah. And we got more back here. They just keep on moving back. Well, what do we call that as they like slide back? Well, we can call that a translation. So the first one we said was a reflection, right? That was the first one we did, was a reflection. This second one now, where we slide it, that's called a translation. On a graph, it might be like up 3, over to the left 2. Okay, those are translations. Whereas reflections, they reflect over a point, kind of like a mirror, right? And then lastly, rotations. Well, I don't see any rotations here necessarily. Maybe if the building changed directions and we were using the same trusses, that could work. But nothing in this one that I can tell from looking at it. Okay, now looking at some of these hurricane ties, that's what they're called, right? Simpson strong tie. So you can use these just like tie rafters in, they're basically rafter tie type things. If you look at this one over here, speaking of rotations, that one kind of looks like it might have a little rotation going on. It is three-dimensional, so it's a little bit harder to describe, I'd say, but we can see that it's basically like reflected up, right? So if you say that this is, so let's say that this is the original one, we would reflect up, right? And then kind of rotate it like 90 degrees to flatten it out to work against this guy rather than in this position. We'll actually look at those hands-on in class. I think it will make a little more sense when you see it in that three-dimensional world. Here, I'm looking at this guy and I'm thinking, well, if I were to just draw something right down the middle of it, right, that's basically just a reflection right over it, you know? It was the same thing on each side of that vertical line. Oh man, now we're talking, ladies and gentlemen. Alright, so why don't I draw in, we'll call this common breezeway the y-axis, this guy my x-axis, that thick wall, it's usually like a firewall they'll call it. Okay, so what's going on? Well, how about this? I'm going to give this an A, a B, C, and D for my units here, okay? So, to go from A to B, what did we do? Sure as heck looks like to me that we just reflected right over that y-axis, right? Just master bedrooms right there. The bed number 2 is there. I'm reflecting over that y-axis. Now from B to C, same type of deal, but we're going over the x-axis. Okay. So let's do this. How do you get from A all the way to C? Well, there's a couple ways of doing it. One, you'd reflect over the y, then over the x. Or, could you do it in one transformation? Ooh, rotations. We talked a little bit about it with the hurricane tie. It's hard to see in that one. But this one, if you were to rotate this 180 degrees about the origin, you would end up with unit C. From A to C is 180 degree rotation. That's pretty cool. I like that. The same would go from B to C. 180 degree rotation. We're getting about it really positive is actually counterclockwise. Negative is actually clockwise, which seems a little bit weird. The result is the same. 180 degrees clockwise, which would be a negative 180 degree rotation, or 180 degrees counterclockwise, which would be a positive rotation, would get you the same result. That's pretty cool. All right, now we're looking at another, looks like apartment complex of some kind. Don't worry about those green and yellow and whatnot colors. Let's talk. I'm just gonna pop some letters down. We'll talk from one to the next. All right. So let's say that this is Unit A. How would we get to Unit B? Well, depending on how far it's actually moving or whatever the dimensions are, we're basically moving it to the right. You know, like a translation to the right. And if these guys were, say, you know, let's give some units. Let's say these were 50 feet. Okay? It'd be a translation to the right 50 feet to get from A to B. Okay? That's how you would describe that. How would I get from A to C? Well, to get from A to C, that'd be a reflection across this hallway here. A vertical reflection would pop me over to that one. All right. So we're seeing some interesting things here. How about from A to D? Well, if A to B was 50 feet and these guys are all the same, right, that'd be 100 feet. So we'd say from A to D would be translation of 100 feet to the right. All right. Are we enjoying that or what? So much fun. So now we're getting into maybe a little more like pure math, as we'll say sometimes. So what's going on the left-hand side here? Let's say to go from this guy, this one here, A to B. What do we have going on there? Well, I see it as reflecting over my x-axis. Reflect over x-axis. Cool. That's good enough for that one. And then over here, I think we're doing the same thing, but reflect over y-axis. All right, so we can reflect over any one of our axes. We can also reflect over lines. So with that in mind, what are we doing here? Well, if I were to draw a line in right here, that would be our y equals -1, right? Y equals is a horizontal line. If I would reflect over that line to go from, we'll call it A to B. So that would be reflect over y equals -1. Okay, that'd be describing our transformation. That's what we'd be asking you to do there. All right, so what's going on in this one here? I'm going to give these a little A and B action again because it's nice and easy to talk about them that way. I can just say A and B and you'll know what I'm talking about. Well, what's happening here? It's in like almost like diagonally away from each other, but it's not like I just like moved them, you know, slid them over to the left and to the right or down and to the left. You know, there's something else going on here. And there's a couple ways of actually describing this one. So I want to do something real quick. So if I were to reflect A over the x-axis, right, the horizontal axis, this point would stay the same, okay? Then this point up here would go down here. Let's see here. This point here would also flip right over to here. And this one right here would end up here if I were to go over the x-axis. So I'm going to connect some dots best I can with my finger. Boom. Okay. So I've just reflected that over the x-axis, but I still need to do something more. Well, hold the phone. What if I were to take this point here and reflect it over the y-axis? I'd end up right here. And this one, I would stay in the same spot, right? Over here, I would end up at this point, and here I would end up over here. And one way that I like looking at this, or it makes sense to me, is that we're 3 away for this point from the y-axis, so I got to be 3 away over here. I'm right on it, so I'm right on it. Over this one, I'm 1 away, so I got to be 1 away over here. And then obviously this guy here, 2 away, 2 away. Okay? So, a couple ways of calling this one out. I could say, we could type. Okay, so I reflect over x-axis, then y-axis, right? So I can do that. as well. That's one totally acceptable thing to say there. What else could we do? Well, you know what's equivalent to a reflection over x then y, or y then x? Ooh. Rotate 180 degrees about the origin. And you can rotate around any point. In this case, we're just rotating about the origin right there, okay? So that would be another equivalent one. Or you could say reflect over the y then the x, right? So there's a few of them we could actually say here. All right, looks like we're dealing with multiple transformations once again. So what's going on with this one? Well, let's see here. It looks like from the yellow one to the green one, like the green one's moved up a little bit, but also it's over, but looks like a reflection maybe, but it's not just one movement, okay? So let's see here. What if I were to take ABCD, I were to move it up one, so it was on like the same level as that green one. So I'd have a point here, which we'd call A prime. When you move it, you put a prime after it, okay? And then we'd have B prime. Move C up, we'd have C prime. And move D up one, and we'd have D prime. Okay. Now if I were to connect these dots, again, best I can, that was pretty good. I have translated this up 1 unit, but there's still more. What do I need to do now? Well, I'm looking at this, I'm thinking, hey, this line right in the middle, could I reflect over that? Well, let's see. For this one, for A, I'm 1 away, so if I were to go 1 away, I'd end up here. How about for B? Well, B, I am 1, 2, 3 away. So if I go 1, 2, 3 away, ooh, hoo, 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 this is working out. So this is, we'll call it A double prime, B double prime. And then let's see here. How about C? Does C check out? C, I am 1, 2, 3, 4 away from that blue line. 1, 2, 3, 4 away. Heck yeah. And let's hope that D works out. 1, 2. 1, 2. Perfect. Excellent. So this guy here is C double prime. This one is D double prime. All right, so what happened? Let's see here. How do we describe this? Well, first, and I'm going to type this out so it's nice and neat. First, we did a translation up 1, and then a reflection over the line. That's a vertical line, so it's x equals -1. I think that's pretty good. Translation up 1, and then reflect over the line x equals -1. Cool. Alrighty, now it's kind of going the other way. Rather than describing the transformations, we're going to draw it given a transformation. So where would the shape be if the quadrilateral ABCD were translated 3 units to the left and 2 units up? Well, if I move 3 units to the left, so let's take A for example. Whoop, there it is. 3 units to the left, 1, 2, 3, and 2 units up, 1, 2. I'm going to be at the point -3, +4. Let's put A prime there. -3, oop, that is terrible. -3, +4. So that is A prime. Okay. And we'll do the same with B. So 2 units to the left, or sorry, 3 units to the left, and then 2 units up. So 3 to the left and 2 up would put me right here. That's B prime. C. Let's see here. 3 units to the left and 2 units up would put me right here. And then D prime. 3 units to the left, 2 up. Just doing the same thing over and over. D prime. Let's see if we connect these dots best I can. Although pretty terrible as far as my dots and things like that, I think this worked out pretty good. That certainly looks like that shape has just been moved 3 units to the left and 2 units up. Alright, so what would we have to do if we wanted to rotate this shape 90 degrees counterclockwise around the point -1, +1? Well, I think the first thing we want to do is probably plot that point -1, +1 right there that I kind of got on that point. Okay. So, there's a couple ways of going about this. Sometimes just memorizing certain little tricks and stuff like that, but let's look at it visually, okay? Because we're in a very visual class. Alright. One of my favorite ways of looking at this is with triangles. So if I were to draw a right triangle, like so, whoa, let's try that again. Boom, I like that much better. Okay, so that right triangle there, it's rotating on the point -1, 1, and I want to rotate this guy. So where would that end up? Well, if I'm rotating that triangle 90 degrees counterclockwise, it's going to look something like this, right? This right here is a 90-degree rotation. Yeah, just kind of turned on its side, which would put A right here, which would be A prime in that case. I like it. So that rotated it 90 degrees counterclockwise. Cool, cool. Okie doke. So, let's continue. How about for B? Well, if I look at B in the same way, let's see here, I would be doing something like this. Alright. Now, if I want to rotate that up, let's see here, it went over 3, so I'd be going, my new triangle would look something like this. If I drew it nicely, that would land B right up here. Alright. So again, I have rotated my triangle 90 degrees counterclockwise. You think of that base, that horizontal base that was 3 units long there, is now vertical 3 units long. I just tipped it up. Okay? And we can continue to do the same with C and D. I'm going to see if I can get rid of some of this stuff because it gets real messy real quick. Alright, let's continue. So now I got to get C rotated. Well, C is just 4 units away, so that's going to become 4 units away. Woo! Way up there. Cool. See if I can move all this. Yes. Okay. Sorry, it's getting a little high up for me to write on what I have here. So C ends up here. So that's C prime. And once again, we can see that 90-degree rotation, right? That's what's going on there. We're basically flipping it up. And then lastly, let's go with D. So with D, we've got a right triangle like so. So if I want to tip that guy up, I'm going to have a right triangle like this with now a vertical leg of 2 and a horizontal leg of 1. So my new point is right here. D prime. And if I connect all these dots, I've got myself the same shape, but it's just been rotated 90 degrees about the point -1, 1. Bippity boppity.